Our Earth is special. It has this wonderful thing called an atmosphere. We breathe it, it protects us from harmful rays, and it keeps our planet warm. But here's the thing, this precious blanket of air is slowly leaking into space. Yes, you heard that right. Every day, about 90 tons of our atmosphere escapes into the vast emptiness. Now, before you start panicking, understand this, it's a very, very slow leak. It's like a tiny hole in a giant balloon. It's going to take billions of years for this to become a serious problem. But it's still fascinating to think about, isn't it? This loss happens because of some interesting physics. Imagine tiny particles of air, full of energy, bouncing around in our atmosphere. Some of these particles, especially the lighter ones like hydrogen and helium, get so much energy that they break free from Earth's gravitational pull. It's like they're launched into space. So yes, our atmosphere is leaking, but it's a slow and steady process. And while it's happening, our planet has some tricks up its sleeve to keep its atmosphere relatively stable. Now let's talk about how our atmosphere actually escapes. There are two main ways this happens: thermal escape and non-thermal escape. Don't worry, these are just fancy terms for some cool processes. Thermal escape, also known as Jeans escape, is all about heat. When particles in the upper atmosphere get heated by the sun, they move faster and faster. Some of them, especially the lighter ones, gain enough speed to escape Earth's gravity, like a rocket breaking free. Then we have non-thermal escape. This is a bit more complex. Imagine the sun constantly throwing out a stream of charged particles called the solar wind. This wind interacts with our atmosphere and can strip away some of it. There are also other factors like chemical reactions and interactions with Earth's magnetic field that can cause particles to escape. It's like a cosmic game of tug-of-war between Earth trying to hold onto its atmosphere and the sun trying to pull it away. And in this game, both sides are constantly scoring points. We can't talk about atmospheric escape without giving a shout-out to our friendly neighborhood star, the sun. While it provides us with light and warmth, it also plays a significant role in stripping away our atmosphere. Ironic, isn't it? The sun constantly emits a stream of charged particles called the solar wind. It's like a never-ending breeze blowing through space. When this wind hits Earth's atmosphere, it can transfer energy to the particles, giving them enough oomph to escape. And that's not all. The sun also emits powerful bursts of energy called solar flares and coronal mass ejections. These events are like solar sneezes, sending out huge amounts of radiation and charged particles our way. While our planet's magnetic field protects us from the worst of it, these solar outbursts can still enhance atmospheric escape. So the sun gives, and the sun takes away. It's a delicate balance, and understanding this interplay is crucial for understanding the evolution of planetary atmospheres, not just on Earth but throughout the cosmos. Section 4, Maintaining the Balance, Why Earth's Atmosphere Stays Put. So we've established that Earth's atmosphere is leaking into space thanks in part to our sun. But why isn't our planet a barren wasteland like Mars? Why haven't we run out of air? Well, that's because Earth is a pro at replenishing its atmosphere. Firstly, we have volcanoes to thank. These fiery giants release a cocktail of gases including carbon dioxide, water vapor, and nitrogen directly into the atmosphere. Talk about a dramatic entrance, it's like Earth's way of patching up the leaks. Then, there's life itself. Plants, through photosynthesis, absorb carbon dioxide and release oxygen, while other organisms contribute to the cycle of gases in various ways. It's a beautiful, intricate dance of life and atmosphere, working in harmony. And let's not forget Earth's secret weapon, gravity. Our planet's gravitational pull is strong enough to hold on to most of the heavier gases like nitrogen and oxygen, which make up the bulk of our atmosphere. So while the lighter gases might escape, the heavyweights are here to stay, at least for now. Section 5, A Tale of Three Planets, Earth, Mars, and Venus. Now let's step back and compare Earth's atmospheric situation with our planetary neighbors, Mars and Venus. It's like a cosmic case study of what happens when planets lose their atmosphere. Mars, the red planet, is a cautionary tale. It once had a thicker atmosphere, but over billions of years it lost most of it to space. Why? Weaker gravity and the lack of a global magnetic field made it easy for the solar wind to strip it away. Venus, on the other hand, is a case of extremes. It has a super-dense atmosphere, much thicker than Earth's. However, it's also incredibly hot and toxic, with a runaway greenhouse effect. Even though Venus loses atmosphere to the solar wind, it's constantly replenished by volcanic activity. Earth, as we've seen, sits somewhere in between. We have a stable atmosphere thanks to a balance of loss and replenishment. We have a strong enough gravitational pull to hold on to most of our atmosphere, and our magnetic field acts as a shield against the solar wind. These three planets highlight the delicate balance of factors that determine the fate of a planet's atmosphere. Studying them helps us understand the conditions necessary for a planet to support life, and the long-term evolution of planetary systems. It's a reminder that we're part of a vast and ever-changing cosmos, and our planet's story is still being written.